motivation, like biology, like the connection between biology and the computer science. So I really enjoy topics like liveness detection. Of course, there is some biology behind. So you need to understand first what is typical in the human beings, right? So what is typical of live human fingers that cannot be there when people spoof? And I want to give just a few sentences of background to follow this topic. So, as probably most of you know, like biometric systems, right, for identification are subjected to many attacks, especially the spoof attacks, presentation attacks. So people, they really duplicate the identity of someone using artifact like maybe even just a high resolution photograph that is presented to the device, and then you can really access to the device with you can access to the device with actually you can actually see also all the database that I used to in my papers. So and I really report the data there, so you can see the different materials. And it's very easy somehow to like kind of fake somehow the biometric, and with photographs or replay attack through a video, for example, and you present to the system and access to the data, sensitive data of the person, like the person is there. So that was really a concern for biometric, the development, the technology. And so I was really interested in that, and I developed an algorithm to measure somehow through image processing perspiration, right? So perspiration is of course a phenomenon that is present there around the sweat pores of human fingers that is not there when the image is, and I think everyone is probably has seen fingerprint images, right? So you can really see the pores in the live and how that impact the grayscale variability around specific points that are where the sweat pores are located. So I started to use statistics to measure, to characterize these differences in grayscale levels, uniformity, and so on. And I really came up with an algorithm. So based on information fusion, because I fused, they combine different features. Perspiration especially was the domain that I was interested in, and also morphological features. So I could have came up with a very good algorithm. So with my professor, we submitted to a competition, and we really got the best accuracy on a single data set. So internationally, it was really a great achievement. And then after that, there was a project in West Virginia, where we used to study DNA. Right, I was really, DNA is again something that can be processed as engineer, right? So signal processing technique, when you have a good understanding of the biology behind. So the first few months were great in terms of interaction with the forensic lab that we had in West Virginia University. And so I really experienced the interaction with someone with a different expertise. And I really enjoyed to be the lead on that at some point, because I remember at the beginning we had a meeting with my supervisor, and then after understanding how to communicate, right, with biologists, with experts in DNA, then I started to lead myself the project, and it was really a great experience. So we had a publication, and it was a challenging problem because we were really trying to solve the enhancement of degraded DNA. DNA is based on absolute system, right? So we have, in easy word for those who are not expert, so we really have like a system in the US. This actually changes from country to country. So in the US, we have 13 loci. So there are specific positions where alleles, some peaks, let's say in terms of signal processing, are supposed to be. And then this scheme at the end can create the identity profile. So it opened me the mind even further compared to the identity, how this can be represented using different modalities, different signals, different information. So but the problem was that when this evidence is degraded, like at the crime scene, so this system doesn't work very well. So we were trying to enhance these signals, and then also we could reduce in some cases a lot like the error rate. So we were really satisfied. And one challenge there was just to produce the data, right? So we had there again um, our collaborators in the forensic lab, they were really processing our DNA data. So we were collecting even from blood, our blood DNA sample, they were processing it. And it's not really like possible everywhere, because ordering the kits of reagents is very expensive, to access to them. So we had a limited number of samples we could analyze. But still, when there was a funded project, so that was possible, so we could do our research, and I think they is still on. So they are still working on that, and my idea is also to continue on that as well. And then after that, I moved to Charlotte, right? So that was after an experience of 2 years as postdoc in West Virginia, and then 2 more years with a different advisor. So I moved to Charlotte, North Carolina, in a computer vision lab. And also there I had a great experience, 3 years almost. And I started to be interested in estimation of gender, right? So, and here this is a topic very close to my presence here today as a speaker. So the biases in biometric systems, so are they biased, right? And of course now I'm sure that everyone is following the face recognition biases, all the issues, the concerns of these tools that are used by IBM, by all the Facebook, and all the troubles, right, again, for biases. So I investigated myself the fingerprint recognition technology, the biases. I also have a few papers work on that, right? So what I noticed was the decrease in accuracy, more than accuracy. So all started from looking at the match scores. So before making the decision about the identity, so we use like the matcher, and then we produce similarity scores. And then we noticed that this was, I think, 2013, 14, right, when I worked on this. We noticed that genuine scores for females, they were really lower than males. So this technology somehow was working better for men. And if you didn't see yet the movie, there is a movie just released. I watched it last week, and it was really amazing for me. Coded bias is you can really tell how researchers at MIT started this field, this concern about biases in biometrics. So if you see the movie, and she's a woman, so the researcher is a woman, and she just was trying on herself. She's African American, so she was trying on herself a face recognition technology, and there was some problem with it. Then what she did, she put a white mask on, and she found out, okay, it's working better with a white facial mask. So she started to investigate, and finding these really these concerns with the face recognition. And a challenge was, of course, to convince also the public, right, the community. So if you see the movie, I do suggest that you can tell, you can really watch the presentation that she gave, and it really inspired me. And because it's very important to talk also to people, to listen to people who work on similar topics too, and how they go through the same or similar challenges. And I kept working on gender estimation. So I learned many things from that experience. Even if with the grayscale images, I couldn't reach really high accuracy. It was 90%. So I realized that after, again, presenting the work at conferences. So there is a very interesting conference, very nice. I like to attend is computer vision, is a winter application of computer vision. I had a great discussion, great question, and at the conference I met another colleague that we are still working together. Is Carl, is in the University of North Carolina, Wilmington. He's a senior professor, but he really cares about sharing his expertise, right, with junior faculty. Especially, he cares about so helping them with their struggles. So I was there, like, I'm talking about the gender estimation, so, and presenting the results with local textual descriptors. So we that really they were invented from the University, Oulu University in Finland, and I think they are really popular. Before deep learning, they were really so popular during those years, and very efficient. So I could really use differences in texture to estimate gender, to separate fingerprint of male from females. But still there, I said, okay, with this textual information, I cannot reach 100%. So I started to study some more biology about the topic. And then, because I was talking to him, to Carl, and say, I really need to add like more information which is diverse, it's not textual. And I think what I'm trying to say here, every year I started to use together all my expertise. So then when I worked on information fusion, like during the first year of my career, I feel it was a great investment, because even if that time was just a small application in multi-biometrics, then the understanding of combining multiple information at different level, it did help my research and my vision later on. So what, in the sense, so in the case of gender estimation, I was looking in a different domain. I said, okay, it's just because I'm combining textural feature that I cannot push my accuracy to be higher. So I started to investigate some more different domains. So I needed something different than texture, so related to biology. And I found interesting work in forensic. And there they do gender estimation from fingerprint. And I had to understand like chemical processes, right? The reactions, how they collect the sample, which are the challenges, the quantity. So concepts that are completely different than my background, and that was not a limit to me. So I was really, so I feel like when everyone is interested in something, there are no limitation. I mean, there is nothing like, oh, this is like, reaction is not my expertise. I will never understand this paper very well. That's not true. It's just a matter of spending time. we spend time on something, we try to read, we sometimes interact with experts is always a good help. But I think from good papers, you really reading is really the key. So you can connect things and meet and discuss and try to find a right team that can help. And I really want to say that I found two undergraduate students who kind of knocked to my door a few years ago, asking for, be involved in my research. And they had different background. They were from biology department. And I really said, okay, you know what? I have research for you. Let's work together. And it was very successful. So they helped me to understand better biology features, characteristic of fingerprints. So I did find a different domain to work on. And this is a research going on. I will hopefully publish papers soon so I can talk about technically more in details and have like more a technical discussion and presentation of this research, which is always great. And after that, so I really try to write down an outline of my career proposal. So in the US, especially in the US, actually, we have so the goal for junior faculty is to try to have, of course, funded projects support the students, because we are really, it's how the system works, right? So we, as a good faculty, right? So we need to spend our time to write good proposal for like government agencies. We have NSF, we have NIJ, even company, they found research, they're very interested. So we can really involve the students, support them, because they really deserve help. Many students, we know that they do other jobs, right, to support their own studies, so especially in this country. So I really like to help them as much as I can. But they really, especially when I see they are good students, so they really need to spend their time for that. And in as goal, one of the main goal that can really help me in that direction is career award of NSF. So I started to write that, and that was a moment of great understanding, like a few years ago, and I submitted this year for the first time, and it's still pending, so I don't know. We will see. But it was a great, no matter how a proposal goes, right? If you get funded or not, is a great moment to think, to gain vision on many aspects. So one aspect is the research. And there I really concentrated on the understanding the biases. So especially in fingerprint technology where there is not much work done. So I really want, if there is anyone expert in that or that is interested in spending their research effort in correcting biases and understanding the sources. So I really, they really can contact me so I can guide some directions. And so I wanted to put all together. So there was a moment, especially was my first summer at George Mason, and I had the opportunity to really select a few months, just waking in the morning and then writing, right? Okay, I need to write this and this goal, this research goal, this challenge, right? And after spending those months, really spending just my time writing, and it was really, I gained some vision that I didn't have before. And I published a paper in 2019 about part of that, not everything, part of that. And I put for the first time in perspective my little contribution. This is what I felt. So under the same umbrella, the contribution of my previous research, they were all there and everything was making sense. And it was really a good feeling. So it doesn't really matter, if you succeed or not, especially the first time. So failure is really sometimes very good because first of all is saying there is something you not completely understand, so it's a way to get a feedback that is really constructive, right? Someone feedback from the community, from expert, they're saying you have to improve more this, or this is not clear. So it's all a gift to me. So the approach to failure is really like as a gift. Okay, this is not what is not a good direction. Maybe if I follow this advice, this comment that they made, I can really do better and have high quality work. So that's what we want, right? So the approach to failure is, of course, it should be there, right? Rejection. We get people rejected, we get proposal rejected, and we are there. Okay, what did I do wrong? What I can do better, right? And maybe I need more time. Maybe this is something that people are not interested at this time, but I'm sure that this knowledge that I'm acquiring now, I can use it later on for something else. And this always happens. So we never waste our time. So if all the knowledge that I acquire through experiences to people even rejected, proposal rejected, they really help success that are there later on, right? So that's really success is there when you fail a few times. So don't be afraid to make mistakes because it's the moment you learn. And I wanted to spend probably a few sentences on that because it's really there, right, every time. And so I was talking about the first big proposal I wrote and how, again, now it's still not accepted, still pending, but writing it is very important. So all the contributions at some point together. So more in details, I, I was seeing like the biometric system, the fingerprint system in the different aspects altogether. So how they were affected, how this technology was affected from the like demographic biases. And I had all the data, still have all the data to do that kind of research and investigation. So we have latent fingerprint, these databases collected through FBI project that from previous collaboration I could get them released where I am now at George Mason. It was very important. It takes some time to get the right data released, but it's still something we go through even with the IRB approval because we work with human subject. So there is a process that we need to be aware of. And sometimes it takes time, but we need to do things, with rigorously, right? Following really rules. That's very important. And be careful how we use the data encrypted. So, and it should be everything can be done, but we have some rules and restriction, of course, in there. But it's always nice to have like people that they work on data collection with thousands of subjects, because that's probably the great point to start studies, anything. And West Virginia, they still do a lot of work in that sense. And it's always nice to even talk with my colleagues, and I see that they always have like the up to date databases based on the problem that they want to solve. And I learn also from that because I now do myself my own collection. And if I'm interested in a specific task, I'll say, what do I need for this task? And then I started collection. I need people for that, and so on. I need these resources, and the government does support that. They make us in condition to buy even expensive hardware, so we can really play with it, right? So, and even the students, because the best understanding comes from really when we can be in touch with the technology, like 360 degree, right? So all of it. So coming back to biases is, of course, I not only I noticed this performance bias, but also I worked a lot with anti-spoofing algorithms, right? Liveness detection. And I found that also those algorithms, they were of course learning based. So they were affected from some other kind of biases, not demographic, but still based on differences in material, used for spoofing, differences in the kind of attack, right? So they were, because in fingerprint is a technology widely deployed. For researchers, it's very challenging to really succeed in publications, but after you acquire some vision, it's very easy to find, like when you have some knowledge, it's very easy to find then, you know, where the gap is, and you need to do that, right? Or you need to create a new problem. So I do encourage, like, women, but all the students and everyone to have a really great background, so don't ever stop reading and studying and being aware of things, so what's happening, right? And that's very important. We need to I like to read like papers of all the conferences, like computer vision. I like to see what people are doing and which one are. That's a very, very important always. And so I try to connect so performance, security together and see all the algorithms that like gender estimation, liveness detection, they were separated algorithms. Then in the context of bias technology based on fingerprint, they were coming together. So and I still now I like to search on Google like where these biases are. And I see that now the problem is not only from face recognition, artificial intelligence, even in all the machine learning algorithms used in cybersecurity. Now they are under evaluation. Are they biased? Which kind of biases are there? Right? So that's very where the research is going. So we want to understand the sources. And I can mention also the capture bias. So we collect the data with the one device that now is of a model in 10 years can be completely different. So should we, since the technology identification, right, and security, so they involve uh, millions of data, so we really want to optimize our resources, our energy, our time in a way that we don't need to be so attached to the device. So if this is different, then it changes from now. Of course, we are working with touchless. So at some point, we want to be the device be interoperable. So interoperability was very another interesting topic for me. So making the system transparent to device diversity. And that's another bias that I found in this technology. So the quality as well. We in image processing, the quality of the image does impact the performance of the algorithm, right, used. So it's really a first step. And also those quality algorithms, they were biased, right? There were differences in between male and female. So I really, I investigated and I found evidence to support this conclusion, right? And now what recently I'm interested in, I want to change the technology. I'm like, you know, there are these biases to be solved. And I see that they can be sometimes spending effort in doing incremental research. Like, okay, I need to tune to mitigate this from the technology. It's kind of putting a patch there. I don't want to do that, not because it's not important, right? Or it's not the way to go. It's just the way how I feel. I feel like I had some time spent on biology because what we need to do like is always step back. Okay, we are doing machine learning. What machine learning does emulate the way human thinks. So if there is a problem in machine learning, then you need to go back to human intelligence. So you need to investigate more the processes that regulate the human intelligence, our learning, our understanding. And that's very fascinating because we get to know who we are, how our body works, our brain, our learning. And then you can really solve the problems, even in the one of biases in machine learning based system. So you never start from the technology, you go back and you want to add more to your knowledge about how the human beings work, right? As the biological system. And then I'm trying to do something like that to like kind of opening a new direction, completely different, to identify people, which is still based on biometrics, but completely different than the information we are using now. So of course we use it. And this is possible because I'm aware of new image processing technique. Like for example, I started to look at multispectral, hyperspectral imaging. They are completely different, but to the image information like grayscale level RGB, we really need to add a new dimension, something more in the spectral domain, and we really can get some kind of measurements of how part of our body, because still I'm biometric so security, can respond to different lights, right? And then what happens if this, how is the response in female? How is the response in male? So we really found a new domain where these differences like better separated, and not only the demographic bias, but also others. And so just investigate completely different technology that if can separate, if it can detect the demographic bias, capture bias, and so on, is very promising in terms of being unbiased. So this is a kind of little overview of what was my path, and I really didn't say so much about what I'm doing now because we know we are really keeping for now until I don't have evidence that my new technology works and publish really something about it. I'm still uh, uh, talking about it as ongoing research, but I'm really looking forward to share with the community. So hopefully I will be presenting very soon to the community these new results, and what I can now share is very great enthusiasm about this opportunity that I have. So I have all the instruments and resources to do that, and I'm really enjoying exploring and discovering a new technology. So I would enjoy to have some question if anyone wants to have questions, or if you, I think in the poster there are my details. If you want to contact me, email me. My email is emarasco@gmu.edu, so that I can share more about any part that you really are interested in. If you need more guidance, more if you are more curious about any specific aspect of what I talked about today, just feel free to contact me and I can share more. Or if some of you wants just to join my lab or just be visitors, work with my students, that is always something I would enjoy to do. Now, if you have any question, I think my hour is ended, right?
Yes, ma'am. Yes. Dear participants, do you have any questions?
Okay, I cannot hear very well. If you can repeat or maybe type the question.
Yeah. Uh, Dear participants, do you have any questions?
Don't be shy.
Right. I have a question for you, Emanuela.
Yes.
Yeah. Can you just suggest a few areas where we can get the funding for our projects?
That's a very good question. Okay, so from my understanding, and from how things are going now, especially with the agencies in this area, right? So I'm very lucky to live in and work in an area like DC, right, Washington DC, where we really have funding agencies like available and willing to interact with us. Um so the procedure, is always worthy if you have an idea, right? And I want to talk about the area of interest, but first I want to clarify what I think. It's always worthy if you have an idea, if you're really interested in something, to talk about it with different agencies. Because let's say if you talk with 10 agencies, and you may find somebody who is interested and they can guide you towards like what they are really interested in. So maybe your idea is good for them, but they want you to do, in a particular way that helps them. So you need to understand the problems, the issues of the other side, right? Of the agency that or the company. So this is one way. But right now, I think for project, it depends on the program. Like from project, like the career award, I can tell there is, if you develop a new technology, you have better chances. It can be a technology that should solve current issues. So I think now hot topics are definitely biases. So mitigating biases in artificial intelligence is really, machine learning application is really there. So you can, of course, based on the application, because as you can understand, this has really a lot of applications, because now artificial intelligence is really dominating our world. And it can be from even spoof attacks. So I would say solving biases in different technologies that are based on machine learning, automatic decision making. It can be cybersecurity, security, and so on. And there are conferences. There is one conference specifically that was started a few years ago, specifically to mitigate biases. And if you see the main conferences like computer vision, or CVPR, they always have workshops for, how to mitigate biases in machine learning. So not only biometrics, right? So in all the disciplines that use machine learning, you need to find evidence that they are biased with different the data. So you need to have the data, okay, with the labels, additional labels. So for example, demographics, and then find a way to understand the sources and investigate solutions, mitigations, which can be even integrate some aspect of our learning. So how we learn. So you may want, there are like research groups like in Siena in Italy, they do work on biases that affect human intelligence. So I suggest to understand that better and then try to apply to classification models to the automatic decision making. This may be a great direction. You can see they go in parallel, right? And then of course, deep learning. So interpretation of deep learning models, they are really powerful, but we need to, as scientists, we need to explain them clearly. What are these representations? So interpretation, and that is computer vision CBPR, you can really find there a lot of resources. There are all the, most of the researchers, they provide even their code, so you can really have access to advances and try to improve or apply their tools to your own tasks, right? In security, especially in security, cybersecurity too. These are, and also you basically need to learn where is the hardware, right? So if you really want to create something new and at the software level, because that's where my expertise is, right? Not hardware, but you really need to know where the hardware is, right? So for example, hyperspectral imaging, and I'm working now on COVID. So, and the pandemic, of course, anything you do to help the pandemic is likely to be funded, right? And as a researcher, I really feel that part of my time, because this is my position now, so it's my job, even for me, it's like so nice that it's not a job, it's really a job. So I feel committed to help the society in that too. So against the pandemic is another important research area that we can explore. And I'm not sure if you're aware about it, but I got funded a project we are exploring the detection of COVID signs through hyperspectral imaging, and this was funded by NSF this year, and even very quickly reviewed because it's really like an emergency here, right? So I really like to spend part of my time for the solving medical issues. So uh, and there, I mean, you can really combine biomedical devices, the new ones, with the medical diagnosis tasks that you want to optimize, because there is a lot of work. There are needs from doctors, so you always want to suggest. You want to talk with experts and see what they really need, which are the problems, and then go back to your background. What can I do for them? So I did suggest a few areas, but in order to have a project funded is also, you really need to go out there and talk with like the really people who deal with the security of the country. I mean, they need to protect it. What do they need, right? And you go home, and then what can I do using my algorithms, my expertise to help them? You will always find the right match, because you spend years, like students, researchers spend years to become expert and very good in something, and they will always find a way to apply it. And so that's the philosophy from understanding about getting a proposal funded. So, but as topic again, so I suggest to apply new technologies, especially exploring new ways to acquire data. So we have different information there available as input. And then this is of course for deep learning, but then for handcrafted features also, because the data is more accurate, so more information, different dimension, also spectral, and then we can extract better features or additional features. So the data is also very important in this process. So hopefully I answered the question.
Yes, ma'am. Thank you very much for the valuable inputs you have given to us.
Thank you. It was my pleasure. So I really, talked about what happened like in the past 10 years and how things just went like there was not an actual plan. So you just is always about seeing how even during the pandemic, how can you plan things, right? So you just embrace the change, because in life I think we need to learn how to embrace the change and do our best with what we have. So that's probably what I usually do. And I really enjoyed to talk a little bit about my experience. It was really high level, so but and I enjoyed, like just to cover. I think that probably was probably a better way to motivate students, especially women. So do not listen just to yourself, right? Just what you really want to do, and do not stop, even especially if somebody says no to you, reject you in any way. Is just you cannot really limit yourself because someone else or some like reality they is like not standard, right? So you just keep be persistent, so and enjoy, and they will be fine. So it's a success until you just keep putting effort and working hard and smart ways, of course. And that's probably the best advice that I can give.
Thank you very much, Emanuela. That was a wonderful and motivational talk on women vision in security and computer science. We are very much blessed to have you as our speaker today, and your research journey is really appreciated, which blessed you with a funded project of 100,000 US dollars. And we really congratulate you for receiving this wonderful grant from National Science Foundation, United States of America. Once again, we all congratulate you, and happy research from our side, and hope we'll be having another session with you soon with hands-on working.
Yes, that would be great. I really I'm very grateful to the government in the US for the grant, so I could buy the equipment I needed. So I really now I'm on hands on, and I also bought some equipment for the students, and I use that to support the students. So that's very it's really I'm very happy about it. So we really have like the tools to do things, and I will always do that. Now we have as soon as we have like some preliminary results, we will probably continue the project because it's nice that this opportunity was given to us.
And we are very much overwhelmed with your contributions of research, especially in the areas of biometrics, AI, deep learning, machine learning, security, and especially the gender recognition, fingerprint technology, correcting biases, demographic biases, interoperability of all the spectra, etc. And the inputs which you have given is very much valuable to us to focus on our research. And
thank you.
thank
That's
you very
really,
much, Emanuela.
I'm so glad
And
to hear that.
yeah, thank you very much. And I can proudly say that we received the wonderful gifts of Christmas and New Year well in advance, especially with your talk.
Thank you very much. I'm so glad. And thank you again for inviting me. It was really, my pleasure to be here today. And, for any student who attended the talk, they please feel free to reach out, and, and maybe you can visit us one day once COVID goes away, we will be safe, or we can just communicate, interact remotely until we are back safe out there. Be safe, and that's very important.
Yeah. On behalf of our IEEE VIZAG base section, and with special permissions and support from our chair, Dr. Lakshmi Narayana sir, and our IEEE team, and we team of VIZAG, we thank you very much for your special contribution.
Thank you.
And be safe and take care. And I now request our participants to switch on your video for a moment to capture. Thank you. I request our participants to switch on your video for a moment, please.
Off.
No, please switch on your video. Please keep it on.
Okay, okay.
Yeah, that's done. Thank you very much. Be
Thank
safe
you.
and wish you a happy new year and a Christmas in advance.
Thank you. Happy New Year's and Merry Christmas to everyone. Thank you again and have a wonderful day. Here is just morning, so all the days ahead. And I can say I had a good start talking to you. Thank you again.
Have a great day. Be safe and take care. Bye-bye.
Yeah, see you too. Thank you.
Thank you. Thank you,
Bye.
everyone. Thank you.
Bye.
Bye.
Bye.